All right, so this is the last section that we'll have to do virtual notes on. And we're going to start by looking at the book because we're going to be going back and forth. So we're going to look at the book. I'm just waiting for it to pop up. Okay. So we're going to be doing word problems that involve integration. It's kind of like the accumulation of why we've been doing what we've been doing. So the first problem is that Mary runs a small shop that is temporarily disconnected from the power network. The generator provides power. It uses 2 gallons of fuel per hour. How much fuel does she need to keep the shop running from 8 in the morning until 6 in the afternoon? Okay, so you could possibly do this without calculus, but we're going to use it with calculus to show you how it works. So I am going to switch to my whiteboard. And oops, don't ask me why it's on green. I must have used it last in my other lesson. Okay, so example 1, it says that we again have a generator that has 2 gallons of fuel per hour. And the shop runs from 8 a.m. to 6 p.m. So again, I'm going to do this by hand pretty easily to show you that we have 10 hours that it runs at 2 gallons per hour is going to give me 20 gallons of fuel. Probably do it in your head. Okay, but we want to try and put this as an integral. So we have the fuel consumption of T is equal to 2T, so 2 times the hour from T equals 8 to T equals 18. So I think we talked about it in this class where we have to change it to military time. So we would take 12 plus 6 makes 18. So if we write it as an integral, we're going to go from 8 to 18 to dt, we're using t, again, is going to give us 2t from 8 to 18. So we get 2 times 18 minus 2 times 8 gives us 36 minus 16, and we get 20. Same way, much longer, but it still works. So again, it is using calculus to solve the problem. Okay, so let's look at the second problem. Let's look at example 2. Okay, you did one similar to this already in one of the other homework sets, I believe. So we have a marginal cost equals 50 plus the quantity over 1,000. We're going to find the increase in cost as production goes from 50,000 to 80,000. So nothing complicated. They give you an equation. They give you some numbers. I think you had 2 of these and maybe 7.3. Okay, so let me go back here and switch back to the whiteboard. Okay, so we're on example 2. And again, our equation is the marginal cost at Q equals 50 plus Q over 1,000. And we have a production from 50,000 to 80,000. So I'm going to write my integral. So I have 50,000 on the bottom. Smaller number always goes on the bottom, bigger one on the top. I'm going to put the equation they gave us, 50 plus Q over 1,000. Because we're using Q, we need to put DQ. Use the letter that's involved. Okay, so now I'm going to integrate. So I add the Q as a multiplier with 50 plus I'm going to square Q, and then I need to multiply it times the bottom, and I get 2,000 from 50,000 to 80,000. Okay, so when I plug 80,000 in, I get 7.2 million. When I plug 50,000 in, I get 3.75 million. To which we get 3.45 million barrels, I think was what we were talking about. Nope, not barrels. That's the next problem. It's just a marginal cost. So we will get big numbers. We're talking about real problems. So don't be afraid when the number is big. Okay. So let's switch back to the next problem. Okay. So now we're on 7.3, or example 3. So it says an oil well in Texas initially produces at a rate of 2 million barrels of oil per year. The production rate will typically fall 15% per year. How much oil is produced over a 5-year period? Okay, so again, 2 million barrels per year. And the rate falls 15% per year for 5 years. Okay, so anybody who's an accounting major definitely deals with this falling and rising rates. And we're always going to deal with we're going to either add 1, so we're going to do 1 plus the percentage if we're rising, and we're going to do 1 minus the percentage if we're falling. Okay, so the big part of the integral is going to be this 0.85. Okay, and then we're going to go to the t for the amount of time. Okay, the 2 million barrels is an initial value. So the initial value is going to scale my entire function. Okay, and I'm going to go from 5 is the end, but I need to start at year 0. So be careful, don't make it the year 1. We want year 0. And again, we're going to match the letter we're using, so we're going to put dt. So when we integrate this, the 2 again is a scalar. We're not going to take any antiderivative of it, but we're going to take the antiderivative here, which gives me what I was going to write, the 0.85 to the t on the top over the natural log of 0.85. Let me put a point there, you can't really see, from 0 to 5. Okay, so when we plug in 5, so sometimes I'll write this down if I'm trying to remember, hey, I'm going to plug in 5 and then I'm going to plug in 0. Especially when I get numbers like this where they're not super nice to plug in. I'm going to plug in 5, and if I round to 2 decimal places, I get negative 5.46. And when I plug in 0, I get negative 12.31. So notice that I was really careful about writing this because this becomes plus plus. So you might have seen this in some of your other problems. So you do get plus plus. You should get a positive number. Yes, we're losing barrels per year, so we're not going to have 10 barrels by the end of 5 years. We're not going to have 2 every year, but we're not going to have negative barrels. We're not going to somehow give oil back that we're pumping. So we're going to have 6.85 million barrels at the end of 5 years. Okay, one last problem. Let's look at it on, hold on, there it is. The textbook. Okay, a discounted revenue stream. So it says, our company is interested in acquiring a revenue stream that is currently producing at a rate of 50 plus $5,000 per year, where T is measured in years. To obtain current value, you are discounting, so be careful, because sometimes we are not discounting. This time we are discounting. Sometimes in the problem, you're earning money. So do be careful, because that'll change it. At a rate of 6% per year, compounding continuously. So we'll talk about that in a minute. What is the current value of the first 10 years of income from the stream? Okay, so we're going to break this down. On our whiteboard. Okay, so example 4 says, hey, we have this revenue stream that's 50 plus 5t. It says we're discounting, again, we're not earning money, we're discounting at 6% per year for the first 10 years. Okay, and we're compounding continuously. So if you have taken college algebra, then you should have covered continuous compounding. Hopefully, if you've taken some accounting, you've also covered that as well. But the formula for continuous compounding is I equals P E to the RT. So the one where you're compounding monthly and whatnot, that one's much more difficult to remember, but continuous compounding is a little bit easier. So normally we have an initial amount for P because P is the principal, but in this case, it's our revenue stream. So our revenue stream is going to go in place of P. So we're going to put 50 plus 5t in the front. E is our E off of our calculator that we normally do, the E we've been dealing with all semester. Okay. Then we have, again, a discount of 6%. So we're going to have a negative 0.06. And then again, we're dealing with years. T is years. And T goes right there. And we're going to do an integral from 0 to 10. And we're going to put our dt there to say, hey, we do need to antidifferentiate this. Okay. We do know how to do u substitution with that, but it's not going to cancel out this piece. So what we have to do is we're going to have to do Riemann sums. Riemann sums. So we're going to do Riemann sums with 100 intervals. So we're going to switch to Excel and remind ourselves how to do that. Here it is. Switch to Excel. All right. So I will put the formula up here just so you remember. We're doing 50 plus 5t e to the negative 0.06t. Okay. So we have A, which is the left end, B is the right end, then we have the number of intervals, the delta x, and the left end again is 0 to 10. We're going to do 100 intervals. Delta x, we're going to take B4 minus B3, put it in parentheses. We have to do the subtraction before we do the division, especially with a 0 involved. We don't want to play around with that. Divided by B5. Okay, so we have x mid x sub n, f of x or f of x sub n, the area of the rectangle, the sum of the area. So we're going to do 1, 2, fill in all the way to 100. The mid x sub n, again, we're not doing right-hand sums anymore, only mid point sums. So we're going to do the left end, which is B3, plus A9 minus half of it, so we're in the middle, times delta x, which is B6. Quick fill down. The function, we need to take 50 plus 5 times B9. Remember the last column before, times EXP, negative 0.06, times, again, B9. Same thing. EXP doesn't have the caret. You can write it with, it doesn't have the times in between EXP there. There's a times in between the front parentheses and E only. And quick fill that down. We get equals, we're going to take C9, again, times the delta x. That's the length times the width, or the base times the height. The sum of the area, we're going to add everything up in that area of the rectangle formula. So the sum, we're going to say that we're going to make sure that D9 stays the same. And then we're going to change it as we go down. So we're going to only add D9 in this one. The next one down is going to take, let me quick fill that down. The next one takes D9, but then adds all the way to D10 and so on and so forth. Then we're going to have to offset. So we're going to do offset. Again, you're going to pick the very beginning so that after the cell that we're going to put in here, which would be E8, right after that cell, it's going to start counting all of the things that we want. We're going to put B5 so that it knows we want to go all the way down 100. If I were to ask you to change it for any reason, then if I put 200 in there or 50 in there, you wouldn't have to worry about changing your offset command. And then we're not going to go anywhere left or right. So 0. So for this particular formula, your amount of money that you earn, because we're discounting, is $545.30. So pretty easy. Again, our workbook is the same as the workbook was in 7.1 and 7.2. The only difference between all the other workbooks is, again, this workbook matches 7.2 because they're midpoint sums. Everything else should kind of match between these types of problems. If you're having any issues, just let me know.